We're gonna switch over to Barry at Fannie Mae. Barry, let's get you unmuted, and you're unmuted. Let's do a quick sound check.
I am here. Can you hear me?
I can hear you loud and clear. So we'll get you to share your screen. And so Barry has been another longtime friend of Sonatype, as well as the whole team over there at Fannie Mae. I've had the pleasure of working with many of colleagues of Barry. We've done panel sessions. We've been speaking at different conferences. And the cool thing about Fannie Mae, over the years that I've been working with them, is that they're on this DevSecOps journey, and they were on the DevSecOps journey a couple of years ago, and they keep improving and maturing their practices around this. And I think the important part of that is, it's a journey. There's not a destination. There's always room to improve, to innovate, to kind of think about new approaches to this. So I'm really excited to hear from Barry and kind of the latest updates of what part of Fannie Mae is working on as they think about DevOps and DevSecOps and scaling in their enterprise. So I'm sure Barry will give you a little more background as to kind of what's happening at Fannie Mae, their organization, and so forth. But really looking forward to this, Barry. So why don't I hand it over to you and let you go here?
Hey, thanks, Derek. I appreciate the gracious introduction. I want to make sure you can see my screen, Scaling DevOps to the Enterprise.
Yep, absolutely. Full screen.
Great. Hey, so as Derek introduced me, my name is Barry Snyder. I'm the DevOps product manager for our enterprise model. Now, through the industry talks, there's a couple different. What I've seen is two primary models. I guess there could be an in-between model as well, where you have a single platform that is scaled across the enterprise, and then you have other organizations where every group, project, or whatever has its own form of DevOps that needs to meet specific needs. Now, we're primarily in the camp of a single enterprise model, but then we have groups, for example, our Salesforce work is they have their own DevOps model just because we can't scale at this point to introduce the management of Salesforce from a DevOps perspective. But with that said, before I step into, there we go. So with that said, let me talk a little bit about Fannie Mae so we're all on the same page. Everybody knows who we are. We provide liquidity to the housing market. And what does this mean? Well, what it means is that banks give loans out to individuals to buy homes. Banks have a limited amount of money that they can give out loans to. So what they do is we take those loans are bundled and resold to investors who then collect on 30 years of interest. What this does for the bank, it enables them to free up money so they can give out more loans. So, before Fannie and Freddie were established, for example, there was not a lot of money to go around, and owning a home was a luxury versus the common family being able to own and have their own home itself. So that's a little bit about what Fannie Mae does. What we are like, everything about us, though, is when you talk to, our technology, we have 468 applications, and then we have 1,200 software assets in our production environment. Those software, each of those, the 468 is a software asset each, and then the remaining approximately was about 40-some components. Are third-party utility or party utilities, in-house built components that sit between systems. They're not full-blown applications, but yet there's something that does a particular function internally. Now we have 9 portfolios, 6 business and 3 corporate. We're primarily a Java shop with about 70% of our work is Java. We have a very sizable footprint of TIBCO, SOA services, and Microsoft is a very large part of us as well. Most of our software these days is 80 to 90% open source. And when we did a scan, our most recent scan is we're actually pushing, I just looked at the numbers last night, around 19,000 open source components. We have 21,000 components that comprise our software in a production environment. So what's different about us as well is that we are what's called a government-sponsored entity. So, and I kind of like a look at this is that we're the best, quote and unquote, worlds of both government agency and commercial. So with the flavor of government comes a lot of heavyweight processes, heavy in governance. And this has been one of our biggest challenges in deploying DevOps within the Fannie Mae framework, is that we needed to move fast. We needed transparency in our governance. We needed to automate that. We needed to reduce the long lead times that occurred because of governance, which are due to a lot of handoffs. And governance was occurring, like for example, when I built some software there early in my tenure at Fannie Mae. And I got our security scan at the very end, weeks before we were supposed to go release to production. So we had to scramble to make those changes. And that gives us to, left shifting that became a very important element. Breaking down the silos, eliminating redundant governance processes. And we achieved a lot of this through DevOps, but there were also some other efforts that went on as well. That brings me, so what changed all this? And prior to 2012 and the housing market and everything that occurred in the late 2000s, Fannie Mae came under the gun, and we became heavily governed at that point in time. And that is one of the big things that changed us. Is first we had to fix all of our problems. At that time, we were scrambling very quickly. I wasn't with Fannie Mae at this time, but one of the drivers is to put processes in place. And unfortunately, we were under the gun and being monitored very closely. So a lot of the focused on manual governance, which is put us into a spot in 2012 where, for example, a deployment of any software took 9 to 18 months, and we were on waterfall. So in around 2014, I think it was, or 2013, started this simplification drive. And then 2014 is when, things really started to take off. And it became a strategic initiative, is that, as an organization, with the changes that were coming in the financial and housing market, we couldn't compete. So, for example, 30% projected growth in households for the next 5 years. And I think this was set at 2014. We were shifting our business model from investing to a flow of fees. So one of the things we would do is we would hold on to a bundled set of mortgages, which created risk for the investors as well as the government. That, and when things happened in the 2000s, the IRS came in and gave us the money to cover up all the bad loans. We wanted to modernize how we distributed credit risk, change in competition, so more people were going to be able to enter the market. Market was becoming more segmented, and then just a general acceleration in the ecosystem of technology around the housing finance. So this really drove 3 strategic initiatives: shifting culture, simplifying everything, going lean, aka going lean, and driving us so we could innovate. Because right now, with all the governance, all the manual processes, teams would actually have a person, and this is no longer true today, they would have a person who specialized in doing nothing but submitting tickets. So my first project, it was like, well, why do we need this person here? And then after we started moving forward, this person for 4 months did nothing but submit and monitor and track and get tickets to resolution. And that just stifled innovation. And then we also, how do we build software? And this is where DevOps came about. So DevOps became a big piece of this in terms of us driving towards faster, more leaner ways of building software. So just to emphasize a little bit of what I just talked about, in 2012, and this is when I joined, is, we had an 18-month, an average size application, or big, would take anywhere between 18 months. Some of the larger ones took, the outliers would take 2 years literally. But I built out a SOA service. SOA services took me, my developer, and a single developer, but we had an analyst, the ticket person, an architect, 6 weeks to build out the SOA service. It was an enterprise calendar service. Yet it took us a total of 4 months to get through all the documentation. This was an agile project, and I kind of use that with quotes again, because I had 67 documents that I had to put together, and this was for a single SOA service. I had, I think it was an 87-page architecture document. Now, I will say today that is all gone. We now have projects that are releasing every month. We have some projects that are actually starting to push the boundary, and they're releasing every sprint. In 2012, we also had 5 to 6 inspection points that involved 32 different stakeholder groups with 100% inspection. That meant every application that released to production had to go through every gate and meet all the criteria or get waived from the stakeholders. Today, we have one working group, and we call that a working group. It's run by EA. We have a cab inspection. That is, that before something releases to production, we go through a cab. This is pretty industry standard, and only 5% of our applications that release to production are actually go through an inspection. So, and this is sometimes it's driven. So there's a percentage of these that are driven by risk, and then there's kind of like a random lottery that comes out. And this is the last data point here I always thought was very interesting, because it gave insight to how people thought about open source at Fannie Mae and how we built out our software supply chain, or did not have the concept of software supply chain. We had 814 recorded libraries in our production. So this is captured in our CMDB. And I remember our new CTO came in, and the owners of that said, no, we have 814. Well, we had brought in Nexus to started scanning, and I think out of 50 applications we had scanned, we had identified 8,000 open source libraries in production, and those libraries had we're seeing a 26%, 26% of them have critical vulnerabilities. Eventually, we've gotten to the point today where, through the scanning, we have complete transparency. We're at 19,000 and growing open source libraries, with only 5% having some form of critical vulnerabilities. That 5% actually all have waivers of some form or another. Typically, the waivers are because, one, there is no other option for that library. 2, it's tied to other critical functionality that has been deprecated in a future version of the library, so they can't upgrade at this point, though they're on a roadmap to upgrade. Or 3, there's a waiver because they're not using any of the functionality that exposes the critical vulnerability. So, and the last piece I want to talk to in terms of the slide is, this is a heat map that's generated of our overall quality of the applications. The application, you'll see the one in the reds and browns, we call this the fall colors. This is Fannie Mae in 2012. This is our initial scan. Actually, it's 2014. The quality was actually a little bit worse, but not that much changed, because we started doing static code scanning around 2013. And then you'll actually see in the bottom, that is end of last year, and you can actually see we've gone to what we call the spring, and this is starting to go late spring, because you'll see a lot of dark greens. So this is kind of getting into our overall code quality, and this is our, so yeah, my flow got disrupted. I changed this at the last minute. So I'll talk briefly in a minute about the quality and how we've reached that level. What I want to talk about, though, first is because this ties into our overall quality play, is our DevOps framework. We originally started with more of, we centralized on, Agile was being implemented. We needed a tool to support that. Jira was the tool we went with. We actually had 3 different tools at one time, but we've consolidated on the Atlassian suite. And that was primarily because at the time we just saw the Agile as a separate entity from our DevOps. And within our DevOps environment, we started with CI, and we got an early lift by using an in-house built tool for deployment. Now, the CI piece we built out around Jenkins, and as I think a lot of organizations do, the Jenkins job started getting expanded outwards, and tying into your automated testing, and then obviously going from your Git repo to pull the code in, build, stage in Sonatype, and then calling upon the testing and the static code scanning. And then we actually use Jenkins jobs to launch our deployment tool. So one of the things that we were looking at is how can we improve, and Derek mentioned is that it's a journey, and it's very much so, because we've always looking where's our biggest pain point. Going to the theory of constraints is when you alleviate one pain point, which we had a lot, you're going to then expose the next one, then the next one, then the next one. Our big pain point ended up becoming our release orchestration. So we have 31 tools that comprise our DevOps, and this is where we rethought, and we started thinking about it as a product, and I'll talk a little bit more about that later as well. But we started thinking of it as a product, and we needed a release orchestration. So we have the deployment automation in terms of the CI to hitting production across our different environments, but we needed an end-to-end, because we started saying that our DevOps begins with a funded idea, and then it ends with the Agile is working software as your measure of progress to working software in production. And then as we started looking at this too, we started looking at all these tools, we realized we have so much data that extracting that information becomes very heavyweight, very painful. So what we ended up doing was also building up our DevOps intelligence. And we have 2 pieces around that. We have an in-house built data mart that actually has overlaid with Tableau. And then we also have used TensorFlow, some machine learning, because there's so much data, it can go through and look for the trending and provide that information. So this is our DevOps environment today. And I want to touch real briefly. This is an article I wrote with Dr. Curtis. It's been published in IEEE that actually talks about how we measured our transformation. And this ended up becoming very critical in the last year or two when we hit some of the major pain points, but we started looking and saying, where's really our next stage of improvement? Because we realized it's an ever-going journey. It doesn't end. Improvement is something you do constantly. It's both wound into Agile as well as Lean. So one of the keys to the pipeline is our supply chain. And this is something we did early on. This is one of the things I think we did right early on. And it was really thanks to Derek and them that introduced this concept to us. But interestingly enough, and we merged the concept from the component with the code, because interestingly enough, the same conversation was going on in the static code arena. So I straddled software quality was one of my areas. So software quality, I had the component quality as well as static code quality. So our supply chain, how we looked at our supply chain was you have commercial components that come from the outside. You have open source components that also come from the outside. And then we are also building, a lot of people think of static, code, but a component in open source is nothing more than code compiled into a component. So we switched our thinking at Fannie Mae is that all the code we build internal, they're components, and they're really no different than open source components. And this is the interesting part is when we started using our static code scanning, we started seeing that the open source components in general were a higher level of quality. And this goes to a number of factors where you have communities that are building a solution. So you have many eyes looking at it. And I believe John, or at least I've heard John talk about this before, the more eyes you have on a bug or a problem, the more likely you're going to discover it and solve it. So within Fannie Mae, we switched our thinking and said these are just components, and then we put in place tools that would manage this. So, we had our automated code scanning. So this is one of the activities we did. We wanted to automate this. At the point, all static code scanning was a very manual effort. And so what we ended up doing was putting multiple tools in place that fit different needs. So, we use CAST to get us the enterprise view and structural quality, which is your design, how you've written your code, as well as your architecture of your application. SonarCube is our tool that we use for component, and then we use Crucible for our peer reviews. Now, in terms of our component lifecycle, we actually put together a model of what we expected this to look like, how it was going to be governed. And this is one of the things that we automated that led us to automate the policy for transparency. So we had 21 policies: legal, infosec, enterprise architecture, and general code practices that were established by us for component quality. And one of these was, unless there's no other exception, you could not use a component more than 2 years old. So it literally was cleaning the component quality in our enterprise. Towards this end, we put into play 2 years ago, using Nexus, we put into play quarantine. So you would actually go through your POM file out to Central Maven or one of the other repos, and then that component would be run through the policies that we had built out, and then it would automatically quarantine. So if you pulled something in. Now, we did put into place through ServiceNow a way to request a waiver that then would be automated. It would be, a waiver would be applied through an automated process within Nexus. What we've implemented back in March is, so we got people used to building and using quality, and that itself, by just putting that tool in place for developers, that drove a huge amount of quality play itself. But now what we've done in this year is we're now breaking the build, and anybody going into production, their build gets broken. You go through the Nexus, and if it finds any critical vulnerabilities, your build is broken, you can't deploy. Now, we left shift this, so this scan is available to developers through the Jenkins jobs. I go through and I'm doing before I even merge with my trunk, I run this through. I'll be able to identify any component with a vulnerability. Now, this also begs the question is that once you're in production, components vulnerabilities can be found at any point in time. So what we've done is we've also automated our, using the Nexus suite, is the notification. So as soon as a vulnerability is found in the environment, it comes back. Everybody who, every application, their technical owner, product owner, they have a support team, our operations group, and InfoSec all receive emails for these. There was actually a vulnerability that was found, and I cannot recall the name, what component it was, but there was a vulnerability found for web apps externally facing. We're actually able to use Nexus and be able to pull up literally, so we had the request come through, we pulled up the request of all the applications that are using that component in that particular version, and then sent it off. It's very fascinating because when we've gone through these fire drills in the past, it's literally an exercise of weeks, if not, I've seen some of these drag out for a couple of months, of going out and finding all the applications, engaging that team, getting them to self-identify. Yes, we don't have it. We don't. With the Nexus, we can actually identify it now at the snap of the finger. So when we were doing that, we're talking about constant improvements. It wasn't as fast as we wanted it. So we've actually are starting to initiate some improvements to accelerate that as well. So I talked about earlier is, these are the improvements we've achieved. Through the various different measures we've had, we've seen an increase in our productivity, a significant drop in our costs, as well as an increase in our quality. But we still have a long way to go. And we're still monitoring and measuring our improvements. And towards this end, for example, is that we're seeing an average increase of 10% in quality. And we're going back and saying, what can we do to make this even better? So and I kind of, what I would have told myself 3.5 years ago, is approach DevOps as a product. If you're going to enterprise scale it, you need to treat it as a product. If you're going to be one-offs, like a lot of companies I talked about earlier doing individual product DevOps as a practice within the team, then that is I wouldn't treat it as a product. But if it's going to be scaled at the enterprise, you need to treat it as a product. You need to approach it as a product. You need to engage your the community, which is your developers. That's my customers, and finding out what their big pain points are and addressing those one by one. It's treated as an end-to-end pipeline. This has led to some pain points, and while I'll talk about everything we've done today, it was not as easy or as pain-free as I talk about in 25 minutes. But the end-to-end pipeline is a key critical thought, because right now we're even finding ourselves having to restitch how we tie together that chain of 31 applications, and we've discovered some gaps in our stitching. And then early is, we got our initial start by looking for our early lifts. We brought in Jenkins because we didn't have it, but we had a deployment tooling platform that has now become one of our biggest hurdles to speed in the organization. Most application teams can't go any faster than a monthly release because this tool actually takes hours. If not, some of the larger applications can take 12 hours to 18 hours to build and deploy and release to production. There's a lot of manual steps in it. It gave us an early lift, but we should have addressed it much sooner than where we're at today. There was some efforts by teams to look at like Ansible to do the automated deployment, extend in Jenkins 2.0. But the one thing we found is with Jenkins jobs, it does not scale. One of our enterprise data, who is 30% of our deployments, has 7,000 Jenkins jobs that they need to manage. For every there's one application in particular, there's 360 Jenkins jobs that they have to go through and manage and deploy. We're cut through our new tooling that we're going with. We're actually cutting that down to 10% of what they started out with or what they manage today. So these are some of the improvements that we're looking at and driving today. So with that, I see my time is coming up to an end. I got 2 minutes left. I just want to wrap up and say thank you for joining me early in the morning and listen to me talk about what we've done.
Barry, that was excellent. I keep saying I'm taking a lot of notes. I might need a new notebook by the end of today on what everyone is sharing here. One of the things, you covered a lot of ground, which was awesome. One of the things I wanted to go back to at the beginning of your presentation, if I can just ask you one question, was in one of the slides you talked about the improvement metrics, and you said, early on you went from 100% manual inspections to 5% manual inspections of anything going through your pipeline. Can you comment on the impact of to the culture on that? Like, what does it mean to be, or what does it feel to be a developer or a DevOps engineer in that environment when you shifted from 100% to 5%? How did that improve the culture?
That itself had I lived under that 100% as a developer or leading a team of developers. It is painful. And like I said, there was always someone on the team who was the ticket person, and that it was typically a developer on the team, and they only got the code like maybe 10, 15, if you're lucky, if they're really efficient, maybe 20, 25% of the time. Mm-hmm. And it was the big dread ticket. You submit a ticket, you have to, typically their SLA process is like 10 days. And there's still some ticketing that exists. And I'll just talk to one right now that we're going through. Literally, we got a cancellation because we were told day 9 is that, hey, your ticket it didn't meet the requirements, so we canceled it. And you have to resubmit. This was all tickets before. Anything you would do in your environment, from getting a library to getting a server, you had to submit a ticket for. So we've eliminated almost all of that right now. The only tickets that we have right now revolve around getting your servers configured for a given technology or getting the middleware team to install. Right now, I talk about this as agent deployments. For the most part, the life is tremendously different. A developer is now spending almost all their time writing code, and it's more usually it's the agile teams. They'll get the Scrum Master involved to help with the ticketing or the manager. So even that is being moved off of the teams. You no longer require a specialist who does nothing but tickets. It definitely has had a culture shift because it's allowed individuals to move quicker. It's allowed them to now innovate, and it really has given freedom to the developers to do what they need to do. Now I actually talk a little bit about what we did with Nexus, because before you would take 5.6 weeks to get a minimum, a minor upgrade in a library, and I remember it was Hibernate 3.3.1 to 3.3.2 took 6 weeks. A minor upgrade to get approved, tested, and it went through 5 different governance groups. Today, there's one governance group, and that's InfoSec, who looks at all libraries. But they only look at those libraries that is 1% of libraries that we can't capture. So today, you can actually go directly and pull a library in and use it at freedom. Before, you had to get everything approved. And sometimes it would take, an average was 3 months, sometimes 9 months. And if you're waiting 9 months for a library as a developer, you're either going to go around the system, find an alternative, or ignore it. So this really has changed how developers look, and they can literally today go and get what they need to write the code. They don't have to wait an over long period of time and all the frustrations involved. So it definitely, towards your point, Derek, these examples I give are to demonstrate the fact that it has shifted the culture to one from I'm waiting for tickets, getting frustrated, to one where I have what I need right at my fingertips and I can write the code and solve the problems.
Yeah, I think it kind of harkens me back to yesterday's conversation with Delta about what they were doing to modernize the way they developed software there, because it's a very old enterprise, and they wanted to not only modernize their efforts of how they delivered software, but make it a place that people wanted to come to work. And in the old the winter days, or the red heat map that you had going to the late spring heat map, like this is the kind of place that you want to work, because we have modern practices, because Correct. We have a modern pipeline and so forth. So thanks a lot for sharing that. We are